Welcome to Math Minders Academy. If this is your first time joining us and you are yet to subscribe to our channel, smash the subscribe button, hit the notification bell icon so you won't miss out on any of our tutorial videos. Like, share, and comment your thoughts on this video. Let's go. Today, we are going to look at the surface area and volume of a sectorial-based prism. Most times, we are only familiar with prisms whose uniform cross sections are regular plane shapes that are very common to us, like circles, where we use circle to build a prism. We have the cylinder, or we use a triangle to form the base of a prism to give us a triangular base prism. But we want to explore a bit further to look at what happens if we use a sector as the uniform cross section of a prism. So what it means is that part of a cylinder has been sliced off to give us the pattern that is on our screen now, guys. So when we have this pattern and we are required to find the total surface area and the volume of this particular prism, how do we go about it? This question has appeared sometimes in WAEC examination, and students have difficulty trying to figure out how to really get the total surface area as well as the volume of this prism. So today in this video, we are going to give a detailed solution, step by step, how this can be achieved. So we urge you to stay glued to this channel and enjoy as we navigate along. So we want to look at this particular prism. If we are given some dimensions, such as the height as 15 centimeters, and we are told that the radius of this prism is 7 centimeters. And then the sector that forms the uniform cross section has an angle of 240 degrees. So you are very certain that that is a major sector. Now, we want to find out what are the materials that are used to build up this solid shape, this prism. If we can understand the plane shapes that form the building block of this solid shape, finding the surface area and the volume will be very easy. So we want to look at the net. First, we have a sector. Of course, this sector is duplicated, so we have the top and the base sectors of the same size. So we pick a sector which appears at the top and at the base. What other shape can you see? We have two rectangles, so we have two rectangular surfaces. So but we are picking one because the two rectangles are the same. So we have this rectangle, and what else? So again, we have this curved part of this prism. So if we can find the area of these two sectors, the top sector and the base sector, the two rectangular faces and this curved surface, add these two areas together, that is going to give us the total surface area of this entire prism. So let's proceed to see how this can be made possible. So we have the sector as is given, and we want to proceed to look at how to get the area of both the top and the base sectors. Of course, we know that the area of a sector is theta over 360 times pi r squared. But here we have two sectors, so we are multiplying this formula by 2, and our angle here is 240 degrees. So we have 2 times 240 over 360 times 22 over 7, which is the value of pi. So the value of pi is 22/7, and the radius of this sector is 7. So we've pushed everything into the formula, and we have it as it's showing right now on your screen. So the next thing here is to factor what will the whole of this be. So this is going to give us 616/3 square centimeters. Okay, so we keep that aside. That is the area of two sectors. We proceed to look at the rectangle. Remember, we have two rectangular faces. So we are going to find out the area of one rectangular face, then we multiply by 2, we double it. That will give us the total area of the two rectangular faces. Area of the two rectangular faces will be 2 times 7 centimeters times 15 centimeters. Recall that the 2 here is as a result of the two rectangles that we have as part of the faces of the prism, and the 15 centimeters here represent the height of the prism, which is also the same as the length of this rectangle. So multiplying everything together will give us 210 square centimeters. We keep that aside, and we proceed to look at the curved part of this shape. Okay, how do we get area of this curved part? If we flatten this curved part, it's going to give us a shape in the form of a rectangle. So we are still going to use length times breadth. But here, the breadth is the curved part, which is the same as the curved part of the sector, or the length of arc, the arc of the sector. So we say here that the area of the shape above is the length of the curved part times the height of the shape. So the length of the curved part is the same as the length of the sector. And how do we get length of sector? Is theta over 360 times 2 pi r, okay? And here, our theta, which is the angle, the sectorial angle here, is 240 degrees. We move ahead to key this into the formula. We have 240 over 360 times 2 times 22/7, the value of pi, times 7, which is the radius of the sector, times 15, which is the height of the rectangle, because we are looking for the area of this curved shape. So it's the length of the curved part times height, and that gives us 440 square centimeters. So we put this area down. So we have 3 items that we have been able to get. We've been able to sort out the area of the two sectors, area of the two rectangular faces, and the area of this curved pattern. And so adding them together, we give us the total surface area of the sectorial-based prism. And so we go on now to add them together. As you can see on your screen, when it is added together, we'll get 855.333 square centimeters. The 3, keep recurring. So rounding this up to 1 decimal place as required, or to probably any given accuracy level, will give you what you want. So, but here we are approximating to 1 decimal place, and that will give us 855.3 square centimeters. So guys, that is the total surface area of this sectorial-based prism. We'll move on now to look at the volume. How do we get the volume of this sectorial-based prism? You need to understand the general way of finding the volume of a prism, any prism at all. What's the general principle of finding the volume of a prism, it is the area of uniform cross-section times height. Here, the uniform cross-section of this prism is, a sector. So we'll get the area of one of the sectors, and then we are going to proceed to multiply by the height of this prism. So area of a sector, we have 240 over 360 times 22 over 7 times 7 squared. All right. And that gives us 308 over 7. So since the base, we say area of uniform cross section, just pick one uniform cross section. We have two sectors, pick one, find the area. That gives us 308 over 3 square centimeters. We drop that. So we proceed now to multiply this area by height. And the height of this prism is 15 centimeters. So when we multiply this area, 308 over 3 by 15 centimeters, that's going to give us the volume of this prism. And that, guys, gives us 1,540 cubic centimeters. So that is the volume of this sectorial-based prism. No matter how difficult the prism may look, they all have the same way of getting their total surface area and proceeding to get their volumes. Understand the shapes, the plane shapes that are assembled together to form this prism. If you are able to break the prism into pieces, into their various plane shape parts, you'll be able to see how to get the total surface area. And of course, for the volume, just look at for the uniform cross section, get the area of the uniform cross section and multiply by the height of the prism. That gives you the volume of the prism. Guys, have you found any value in today's tutorial? If you do, and you are yet to subscribe to our channel, go now, hit the subscribe button, click on the notification bell icon so that each time we produce a new video, you'll be among the first to receive it. Go to the comment section, tell us what you feel about this video. Tell us another area of mathematics that you want us to develop a video on. We are going to work on that. We'll see you again in our next tutorial class. This is Math Minders Academy saying goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught